Hello and welcome back to Prescriptive Analytics. So we are going to take an example from marketing here and we'll see how we can use optimization, linear programming, and solve a decision problem for advertising. This is Hari Rajagopalan and I will be completing this video and hopefully this is something you enjoy. So here's a very common problem in advertising. So company is has an advertising budget, 145,000, trying to figure out how to locate it, allocate money. The company has newspaper ads, television commercials as its primary means for advertisement. It knows that each of the first 10 ads will cost about $1,000, expected to reach about 900 new customers. Each of the next 10 newspaper ads will cost $900, expected to reach 700 new customers. And note that the new customers reached by increased amount of advertisement decreases as advertisement saturates the markets. Now assume that the company will purchase no more than 30 newspaper ads and no more than 15 television ads. So there's a limit to what they will purchase. So let's kind of put this all in a table. So here are media, a number of ads. So it's newspaper 1 to 10, newspaper 11 to 20, 21 to 30. And here is this is information given to you, okay? So 900 ads, the first 10, then newspaper, the next 10 gives you 700, and the last 10 gives you 400. And the cost keeps reducing. Similarly, television 1 to 5 reaches about 10,000 people. 6 to 10 reaches 7,500, 11 to 15 reaches about 5,000. And again, cost per ad reduces. So this information is given to you, and you're asked to create a math model and solve using linear programming. Now, before you start working through this model, again, think through what is it that you're asked to do, right? And I want to kind of go through this and this thought process here, because a lot of students get this wrong. And the problem is, the first thing most of you assume is that we are going to minimize our cost, right? Most people say, hey, we're going to go and let's go ahead and minimize our cost. The problem with that approach is that your cost is already fixed. You got $145,000. You are going to spend this. Go spend this, right? So this is fixed. So what you want to do is to maximize the number of customers you reach. Your decision variables, and you can kind of go, here is the decision variable, a number of ads, newspaper ads from 1 to 10, number of newspaper ads 11 to 20, and so on. Now, because this reaches less and less customers, right, the computer will not fill this up before it fills this. The computer will not fill these before it fills this, okay? So in this problem, you don't have to worry about N1 being filled up first before N2 is filled up. But later on, in a different lecture, I'll talk about what happens when you create when this value is more than this value and you're trying to maximize it, and how do we force the computer to fill this first before it fills this, and we'll talk about that. All right, so now that we have thought through this problem, let's go ahead and model it. So let x1 be the number of newspaper ads 1 to 10, x2 newspaper ads 11 to 20, x3 21 to 30, x4 TV ads 1 to 5, x5 6 to 10, x6 11 to 15. Now, because I'm using x1 to x6 because the book does it and I took it from the book, but my advice to all of you is to not use this generic x1 to x6, because you will get lost in these. You'll start putting it in Excel and then you'll start wondering what x1 and x2 are. My advice is to use N1, N2, N3, T1, T2, T3, so that you can kind of identify exactly what that is by looking at the label. All right. So let's go ahead. So advertising, maximize number of customers to reach is our objective. Remember, it's not minimizing cost. It could be minimizing cost, and the practice problem I've given you actually is a minimizing cost problem, but that's a different issue. In this situation, it's a maximizing customers because you have a budget. So you're going to maximize 900x1. Why? Because each ad will reach 900 people. So if you put in 10 ads, that'll be 9,000 people, right? Then 700x2 and so on, right? So you should have a good understanding of how I got these numbers. Subject to, you cannot spend more than $145,000. And therefore, you've got to take the cost of each ad. So 1,000 for each X1, in each newspaper ad up to 10. So 1,000 multiplied by X1 plus 900 multiplied by X2 plus 800 multiplied by X3 and so on. 12,000 is the TV ad, 12,000, 10,000, and 8,000 are the number of TV ads. That's less than 145,000. Also, newspaper ads, you can't do more than 30. So you can do X1 plus X2 plus X3 is less than or equal to 30. But if you go ahead and put X1 is less than 10, X2 is less than 10, and X3 is less than 10, as it is anyway, automatically this will fix the 30. Similarly, TV ads, if you go ahead, instead of putting X4 plus X5 plus X6 is less than 15, you want to make sure that X4 cannot be more than 5. And so X5 is less than 5, X6 is less than 5, right? So once we do this, let's move on to Excel. And here's the setup. This will be the last setup I'm going to set up for all of you from scratch. After this, I'm just going to show you Excel and say, here is the setup. You guys can go and look through it. You will have access to the Excel file. And you'll notice here, we have X1 to X6. Here's your decision variable. Here are your objective coefficient. This is the sum product you're going to maximize. This is the cost. And then here, upper limit, these values will be less than this max value. All right. So let's go to Excel. Okay, so here is the Excel file. And since I've already done, starting with Blue Ridge Hot Tubs to 4 problems where I've done everything from scratch, I'm thinking that for this one, I'm going to walk you through this instead of doing it from scratch, because I did want to also show you the difference between the long format and the short format. So let's go ahead and just walk ourselves through what is being done. So as usual, you start off from X1 to X6. You have the decision variables in the next row, which you leave as blank. And then this is the objective. So you're going to put 900, 700, all the way up to 5,000, right? Here is the sum product for that. Don't forget to put a $sign for the decision variable. And then the next constraint we have here, 1,000, 900, 800, and so on. And it should be less than, I'm going to go ahead and put a less than or equal to here, 145,000. Okay, and so here is the sum product. Okay, now for these constraints, which are specifically applied here, I've just used upper limit or max, and I put all these values 10, 10, 10, and 5, 5, 5. So if you look at this here, it's maximizing the objective, changing the cells, and then here you have the first constraint. The first constraint, which is this is less than that, and then your boundary constraint. This should be in the boundary. There seems to be an issue. There you go. You can see that this is less than this is a boundary constraint. Okay. Now the same thing can be redone in a long format. So here's the long format. Instead of making this boundary constraints, I've actually done the same rectangular format. So your X1 is less than 10, so we put X1 1 here, everything else is 0, the sum product continues, and say it's less than 10. You'll notice that both these styles end up with the same answer. There is no difference. It's whether you want to do it the long way or the short way. My advice is anytime there is a constraint directly without any addition or subtraction, when it's X1, there's no X1 plus X2, but you just have something directly on your decision variable saying this should be at least this much or less than this much, we can use this boundary constraints. In fact, you could even set up a minimum constraint, lower limit, and say each you should be at least one each, and so you can go 1 1 1, and you can do that and then say this is greater than this value. Okay, so I'm not going to do the Excel file. This is the 5th problem, so by now all of you should have a really good understanding of how to do Excel, and if you don't, please get in touch with me, because you'll really struggle if you can't do this.